Welcome back to CAC Academy, guys. If you've made it this far on our website, that means you've watched our 3 previous videos on how to create a synchronous counter for the D flip-flop. In today's session, I will teach you how to create a synchronous counter for the T flip-flop. To create the T flip-flop, we'll be using the same sequence as we did with the D flip-flop. Just to remind you, the sequence goes from 5 to 4, then from 4 to 7, from 7 to 6, and so on. To recap our present and next state columns, you can reference our first video on the D flip-flop. In the interest of time, I will only show you how to fill in the data columns. At this time, I will introduce you to the excitation table for the T flip-flop. When the present state is 0 and the next state is 0, then the output is 0. When the present state is 0 and the next state is 1, then the output is 1. When the present state is 1 and the next state is 0, then the output is 1. And lastly, when the present state is 1 and the next state is 1, then the output is 0. We will use the values for the excitation table to fill in the values for the data columns. We will reference the bits in the present state and the next state using the excitation table to find out the data column. In this case, the present state has a value of 0 and the next state has a value of 0. We will look at this column where the output is 0. This one is the same situation where the present state is 0 and the next state is 0. That means the output will be 0. This was repeated for this column as well, where the present state is 0 and the next state is 0 as well, meaning the output will be 0. This one is a bit different, where the present state is 0 and the next state is 1. When we reference the excitation table, this means the output will be 1. For this case, the present state is 1 and the next state is 1. When we reference the excitation table, this means the output will be 0. I will go ahead and I will fill out the rest of the data columns. For the DB column, we will look at the Q1 and the Q1 plus 1 present and next states. When the present state is 0 and the next state is 1 and we reference the excitation table, the output is 1. When the present state is 0 and the next state is 1, then the output is 1. When the present state is 1 and the next state is 0, then the output is 1. I hope you've gotten the gist of this, and I will continue to fill out the rest of the data columns. So here we have our completed T flip-flop state table. I hope you guys have understood the video, and now I encourage you to watch our video on the T flip-flop corner mapping.